In this lesson, we're going to look at the Pythagorean Theorem. This is lesson 5.7 from the text. Our objectives are to learn and use the Pythagorean Theorem correctly, to identify Pythagorean triples, and to learn and correctly use the Pythagorean inequalities. Now, first thing we need to know about the Pythagorean Theorem. It only applies to right triangles. So if you have an acute triangle or an obtuse triangle, the Pythagorean Theorem does not apply. If you look at the picture, you'll notice a little red box. We use that little red box to denote that the triangle is 90 degrees at that angle, and that makes it a right triangle. So the Pythagorean Theorem only applies to right triangles. Another thing you need to know is we are not going to use the A, B, and C like they're used traditionally in middle school. Traditionally, you ask a middle school student, what is the Pythagorean Theorem? And they will invariably say, A squared plus B squared equals C squared. Well, that's great for getting a middle school student to work with the Pythagorean Theorem. Unfortunately, A, B, and C are not descriptive. They don't really mean anything. So in high school and beyond, it's better to say leg 1, leg 2, and hypotenuse, because those words, those names are more descriptive, and that's exactly what we're going to do. So the Pythagorean Theorem, notice I've got the picture here, leg 1, leg 2, and then the hypotenuse. The hypotenuse is always opposite the 90-degree angle, so the formula is not a squared plus b squared equals c squared, but it's leg 1 squared plus leg 2 squared equals hypotenuse squared. Again, the reason why we're doing this is because A and B and C by themselves are not descriptive. They don't really tell us anything. But when I use leg 1, leg 2, and hypotenuse, that becomes more descriptive of what's happening in the triangle. Find the value of x. Give your answer in simplest radical form. So let's look at part A. I know the two legs, 6 and 4, and it is totally irrelevant which one I call leg 1 and which one I call leg 2. It does not matter. And I have a hypotenuse of x. Again, the hypotenuse is always opposite the right angle. So I can now set up and use the Pythagorean Theorem. Now the textbook is using a squared plus b squared equals c squared, and so that's why I have it here in the presentation. That drives me nuts because it should be saying leg 1 squared plus leg 2 squared equals hypotenuse squared. Anyways, I'll move on from there. Plugging everything in, I get 6 squared plus 4 squared equals x squared. 6 squared is 36, 4 squared is 16. Adding the 2, I get 52. So 52 is equal to x squared. But I have to know what x is. So I take the square root of both sides, and I get x is equal to the square root of 52. And that right there is radical form. But is it simplest radical form? No, it's not simplest. Why? Because 52 can be broken up into 4 times 13, and 4 is a perfect square. 4 is 2 times 2, so 4 can be reduced into a 2 and taken outside of the root. So the simplest radical form is to say that x is equal to 2 square roots of 13. All right, let's look at part B. What are the two legs? Look at the picture carefully. What are the two legs? If you said 5 and x minus 1, you're correct. The hypotenuse is x. So, using the Pythagorean Theorem, 5 plus x minus 1 squared equals x squared. Now, from algebra, we've got to FOIL out the x minus 1. And if that's a skill that you don't have yet, then you need to let me know that so that I can get with you during a math lab or sometime maybe after school or before school so we can sit down and get you good at that, okay? We're going to FOIL that out. And so 5 squared is 25. But when I FOIL out x minus 1 squared, I get x squared minus 2x plus 1 is equal to x squared. Simplify the equation by subtracting x squared on both sides. I end up with negative 2x plus 26 is equal to 0. So I combine like terms. I'm going to add 2x to the other side, divide by 2, and I get x has to be 13. Which means that the sides of the triangle are 5, 13 is the hypotenuse, And do you know what the other leg is? The other leg has to be 12, x minus 1. So 13 minus 1 is 12. What is a Pythagorean triple? The simplest definition of a Pythagorean triple is a set of 3 natural numbers that satisfy the Pythagorean equation. Now you've got to remember from algebra what a natural number is. A natural number is a number like 1, 2, 3, 4, 5, 555, 5,568, 1 million, 1 billion. Those are all natural numbers. A natural number is not a decimal number, like 2.4. A natural number is not an irrational number, like pi. And a natural number is not a negative number, like -3. Natural numbers are whole, positive numbers. They're whole because the whole numbers include 0, but you can't have 0. And it doesn't even make sense to include 0 because the side of a triangle can't be 0. If it were, you wouldn't have a triangle. So for example, 3, 4, and 5 are a Pythagorean triple. Why? Because they satisfy the Pythagorean equation. 3 squared plus 4 squared equals 5 squared. 9 plus 16 is 25, and 25 equals 25. That is a true equation. That's what it means to satisfy the Pythagorean equation. You're going to get the reflexive property at the end. It is a true statement to say that 25 is equal to 25. 7, 24, and 26 are not a Pythagorean triple. Why? Well, 7 squared plus 24 squared, we'll assume at this instance that it equals 26 squared. But when I square 7, I get 49. When I square 24, I get 576. And when I square 26, I get 600. And that's not right. Let me do that again real quick. I hate to have that happen in the video, but it's better that I do this now. 26 squared is 676. So that should not say 675. That should say 676. But it doesn't matter. Even if it says 675, look what happens. I add 49 and 576, and I get 625. That's not a true statement. So 625 does not equal 676. So that means that 7, 24, and 26 are not a Pythagorean triple. Find the missing side length. Tell if the sides form a Pythagorean triple. So I know 12 is a leg, and I know 15 is what? What do you think 15 is? If you said the hypotenuse, you're correct. So the way that this is going to work is I'm going to let the unknown value, my other leg, leg 2, normally I would say leg 2 instead of b, but again, this is from the textbook. So 12 squared plus b squared equals 15 squared. So when I square 15, I get 225. 12 squared is 144. So when I subtract, I get that b squared is 81. So that b has to be the number 9. Now, the side lengths are non-zero whole numbers that satisfy the Pythagorean equation, and that means they form a Pythagorean triple. How about here? This is 15, 9, and then the unknown side. Can you tell me which side we don't know? If you said the hypotenuse, you're correct. 15 and 9 are legs because they're not opposite, they're adjacent to the 90-degree angle. So we are going to set up the Pythagorean theorem. Again, that should say leg 1 squared plus leg 2 squared equals hypotenuse squared. 9 squared is 81, 15 squared is 225, so I get c squared is 306. I take the square root of both sides and I get it into simplest radical form, which is 3 square roots of 34. Now 3 square roots of 34 is irrational. That is not a positive whole number. So therefore, that means that the 3 sides do not form a Pythagorean triple. They do satisfy the Pythagorean equation. You got to be careful there. You can satisfy the Pythagorean equation and yet not be a Pythagorean triple. A Pythagorean triple means that the numbers that end up satisfying the Pythagorean equation are also, in addition, natural numbers, okay? So this does satisfy the Pythagorean equation, but they are not a Pythagorean triple. Pythagorean Inequalities Theorem. Let's look at the first one. If c squared happens to be larger than a squared plus b squared, then what we're dealing with is an obtuse triangle. Now notice this is an inequality. It's not an equality. And the Pythagorean equation deals only with right triangles. However, if the square of the largest side happens to be larger than the sum of the squares of the other two sides, then it turns out that what we're dealing with is an obtuse triangle. The second one, if c squared happens to be less than a squared plus b squared, then it turns out that the triangle that we're dealing with is an acute triangle. So how about 8, 11, and 13? And how about 5.8, 9.3, and 15.6? So let's look at 8, 11, and 13. Let's pretend that these are the sides of a triangle. Now, is the triangle going to be obtuse, acute, or a right angle? Right triangle. Well, 8 squared plus 11 squared, I put down a question mark because I don't know the relationship yet. I don't know if it's equal, I don't know if it's less than or greater than. But I do know that 13 squared is 169. When I add 64 and 121, I get 185. And so that is greater than 169. Now 13 was the longest side of the triangle. So that means that the sum of the two legs squared turned out to be larger. So the square of the hypotenuse was less, which means we're dealing with the second part that's in blue for this inequality theorem. We're dealing with an acute triangle here because the sum of the squares of the legs, this is why I like to use leg 1, leg 2, and hypotenuse instead of A, B, and C, because the sum of the squares of the legs is greater than the largest side squared. Okay, let's look at 5.8, 9.3, and 15.6. 5.8 squared is 33.64. 9.3 squared is 86.49, and 15.6 squared is 243.36. So when it all is said and done, the longest side, 15.6, when I square that, that happens to be larger than the sum of the squares of the legs. So what we're dealing with here is an obtuse triangle because the largest side, 15.6, when you square it, is still larger than adding up the squares of the legs. And so we're dealing with an obtuse triangle. All right, when it's all said and done, even though I had some cases in this lesson where it used A, B, and C, I would encourage you not to use the A, B, and C notation from middle school. Instead, use leg 1, leg 2, and hypotenuse notation simply because it is more descriptive. Know what a Pythagorean triple is. A Pythagorean triple is a set of natural numbers, positive natural numbers, that satisfy the Pythagorean equation. Know how to identify the hypotenuse correctly. Remember, the hypotenuse is always opposite the 90-degree angle. And know how to correctly use the Pythagorean inequalities. So you'll have to know what you're dealing with, whether you have an acute, an obtuse, or a right triangle. That's it. God bless you, wherever you are today.